welcome back to the Obsession Engineering s1000rr refresh project, where we're ready to put the bottom end together. So what I've done here is I've cleaned all the mating faces up of the cases. I've also blown everything down so that there's no debris in anything, including especially all the oil ways and the drains and everything. I've cleaned through the gearbox, and next is I'm just popping the conrod caps back on, making sure the right one is in the right place. Previously I mentioned the cold cracking of conrods. So instead of machining two halves of a conrod, the cap and the main rod, and then bolting them together and then boring a hole in them, these are cast as a single rod, and then they bore the hole in them and then they freeze them and basically snap them in half. So you get this sort of quite rough finish where the grain and the material is a bit more exposed, and that means that when you bolt the two halves together you get a perfect join, and it gives the rod a greater strength. So the next thing I'm going to do is, these are actually the old rod bolts, so I'm going to one by one change the rod bolts, throw the old ones in the bin, and then I can go through the torquing procedure for the new rod bolts. This is one of my new conrod bolts. Looks no different to the old conrod bolt, but it is new and out of the packet. BMW used to have these Loctited into the engine because they went through a little bit of a phase where some of them were falling out. But they have changed the spec on the bolt, and now, like a sort of normal bolt with every other manufacturer, you actually oil the threads and under the head. You also, which is a bit unique to BMW, do a pre-stretch. So this is the first time I've ever come across it on motorbike engines, is you fit the bolt and you actually torque it up to pretty much the specified torque setting, then you undo it again and start again. Now it's unusual this for the turbine industry, motorbike industry, but I come from industrial turbines where we actually do this quite regularly, and what that seems to do is it especially on the mating faces, it beds any imperfections out of it, so that when you go for the correct torquing afterwards, you know everything is perfectly flat. So that's the logic to it. So the first thing I'm going to do is oil them up and do the pre-stretch. Because these bolts, like most conrods, have to be in their elastic region, what you do is you do them to a torque setting and then you do them to an angle. So I've got them to the torque setting, so what I do is I put a mark on the bolt head and on the rod, and then I will also be using my angle gauge on my extension bar, and then I can get an accurate angle turn on the bolt. But just in case the bolt slips, anything like that, it's useful to have this line on so you know within a few degrees where you are. What I've also noticed with these BMW bolts is this is torqued up before the pre-stretch. When I've done the pre-stretch and then torqued them up for the actual tightening, quite regularly these lines are in a different place. So that tells you the bolt has actually bedded and shows you how important the pre-stretch was. So now I've done the pre-stretch, back the bolts off and tighten them back up again to the torque setting. So you can see the line on here compared to here, how much further the bolt has moved around, which shows you how much it has actually bedded in. So it's bedded into the head and probably pulled a little bit of form into the thread as well. So you can see, but they're actually not particularly consistent. That one's moved that bit, that one's probably moved not as much. They've all moved ever so slightly differently, so this goes to prove how important the pre-stretch is on these BMW bolts. Don't get this on everything. This is why you need to read the manual. So that's all the conrod bolts torqued up fully. So that's that job done. And now I've just given everything a bit more of a clean, a bit more of another blowout. Make sure there's no bits of rag or bits of residue or anything anywhere in that half of the engine. I've inspected sort of the bottoms of the pistons and bits as well. Just making sure everything looks good. So, some of you may be asking, what are these holes for in the crankshaft? Well, in the other half of the crankcase, the oil supply comes down here and it supplies oil into the crankshaft into these holes. So it sits in the main bearing, feeds oil into this hole. That then goes through a drilling in the crankshaft and supplies oil to the big end shells. So that is how you get oil into your crankshaft. So obviously if your oil pressure goes down, which is very, very bad, then it doesn't feed enough oil into here, and these bearings can pick up, and more importantly, your big end belt bearings can pick up. So getting oil supply into these holes is critical to engine life. A lot of bikes then have a feed off the other side of the crankcase that fires oil up towards the pistons, but BMW actually run a completely separate oil line to these oil jets down here, which squirt up into the pistons. And interestingly, these oil jets have actually got tiny little non-return valves in them, so that every time you start your bike, there's an oil supply straight away. There you go. That's today's important lesson on oil supply. Before I put the crankcases together, I could also show you, hopefully, a little bit of how you select gears. So we go around this side of the engine, and this is what we refer to as the input shaft. This connects to your gear lever, and you rotate that when you push on your gear lever. Now you come this end, and the same shaft is attached to this. So this sprung-loaded selector pushes on these little pins on this star. So then this star turns around. It's actually quite difficult to do, but turns around and locks in position. What that does in here is it turns this shift drum. Now the shift drum, if you can see, has these little slots cut in it, and the slots have shape to them. The shift fork pins into the slot, so as you rotate the shift fork, the shift drum, like this, the shift fork follows the path and it pushes one way or another. And then that will push, for example, this set of gears into each other, and this gear that's free will then be driven onto this set of gears that's attached to the shaft, and that transmits the power. So it's quite awkward to turn this, but you can see that moves the shift drum and that moves the shift forks. A little bit awkward to show one-handed, but hopefully that gives you some idea of how your gear selector works. I thought I might be able to demonstrate this a little bit better by setting up the camera so I've got both hands free. Whoop! So what I'm going to do is I can turn the selector from here. It also generally helps to turn the gearbox a little bit. And as you can see, as I change gear, the gears move across. Oh, that's first gear. Back into neutral. You can see in neutral, the other shaft isn't really turning, it's just a little bit of drag from the oil. And then as I move through the gears, it slides the gear wheels across, and the dogs engage in the other gears. That does help if there's a bit of drag on the gears, so as you can see, that's all sort of moving along. 6th, 5th, 4th, 3rd, 2nd, neutral, neutral, and 2 seconds, get me tool back in, first. So we'll leave it in neutral because that's easier. So we'll just move this back a little bit so you can see the crankshaft a bit better. So obviously under normal operation, the crankshaft would be spinning round. Spinning round like this. This here is the primary drive. So this, the clutch basket would be here. The primary drive would be spinning the clutch would spin, and when the friction plates are engaged, it would transfer the friction drive to this shaft, the input shaft, and then that, when we select a gear, like that, would then drive the output. So that's where your sprocket goes, and that drives the back wheel. So that is crankshaft into the clutch, which spins the other way, into this shaft, into the output. Easy as that. So this is the bottom half of the main crankcase, and as you can see I've taken all the oil strainers and pressure relief valves and thermostats out of it when I took the engine apart. So what would happen normally is oil strainer would be down here and it'd suck oil up here because the oil pump is just here. So the oil pump would suck the oil up and shoves it towards the oil thermostat. BMW are the only people as far as I know who actually use an oil thermostat. And then it would go up here, and if the oil's cold it will just go straight to the oil filter body. If the oil's hot it will divert through this hole off to the oil cooler and comes back through this hole here. So both of those end up, whether it's gone through the oil cooler or not, in the oil filter where it gets filtered and then goes down that hole. And then from in there it gets fed to several different places. But most importantly, it gets fed into this main rail here, which then feeds off to two of the main bearings, off to the gearbox, supplies to the clutch, all these places, and that's basically your oil system. So what I've done with this is I've cleaned up this half of the case as well. I'm now going to apply crankcase sealant to the other half of the case, the top half, and then I can put the crankcases together. In preparation for putting the two crankcase halves together, I've made sure doubly again that everything's nice and clean, that the dowels are fitted into this half of the case, and on BMW engines you don't have to fit the cam chain or anything, which is common on Japanese stuff. I've also got new O-rings and the new main bearing bolts. Even though they don't say you have to change them, because they go to quite a high stretch value, I think it's a good idea to change them because they're not mega money. I've put a little bit of oil into the crank, just a smear of oil on all the main bearing bits, made sure the gearbox has got a little bit of oil around it. And so the next thing is to apply some sealant. So I'm going to be applying sealant all the way around the outside. Basically, I don't need to do this section, I just need to do where the oil would go outside. So round the back of the gearbox, round these edges, round here and down here. You'll see these little trim bits in here where they put this so that the sealant doesn't go anywhere near the bearing areas. So that's it. I'm going to apply a thinner smear of sealant, and then I can put the two crankcase halves together and get it all tightened up. So we don't need tons and tons of sealant, we just need, a smear everywhere, because what we don't want is the excess, tons of it, to end up back in the oil and blocking up the oil strainer. So that's all the edges done. Now I'll just put the cases together. What I do is I put all of the bolts in all the holes first, so that if the sealant's going off, as it will, then you're not trying to push a bolt through gone off sealant. So the next thing I've done is I've just nipped everything down, and then the main bearing bolts, I've torqued them up because they're a torque setting and a stretch value. So I've torqued them up to their torque setting, and I've marked the heads so that when I do the stretch, it's an easy, quick reference. I will be using the dial gauge again, but it is a quick reference of which ones I've done, just in case, the phone rings or something and you lose track. So I'm going to torque those up, and then I'll move on and do the next set of bolts, exactly the same routine, and then finally all the little M6 bits. And that will be the crankcase halves together. You'll be pleased to know, if you're paying by the hour, I work really fast. So there we go, one set of assembled crankcases. Yes, there is a big hammer, useful for tapping the cases onto the dowels. You can hit things softly with a big hammer, but you can't hit things hard with a little hammer, so always start with the biggest hammer you've got. All the case bolts are done. That's it. I'm going to have a little bit of a lunch break now, and probably go out and make push bike this afternoon while it's nice. This is it. Progress is good. Happy days. Thanks for watching, and join us again next time where we'll be putting the cylinder head back on.